Hi everyone, this is another video. It's for the rate of discount. I'll start with the effective rate of discount and then move on to the formula for the nominal. So here we go. So let's define D as the effective rate of discount as 10% per annum. Effective, say. Now, how do we apply that? Well, this one we apply to a cash flow in the future. So if I draw a quick timeline here, that's in short, yeah. So that timeline is 100 times 0 here, time 1 here. And to get the present value from that, we multiply by 1 minus D in that period. So therefore the present value is 100, 1 minus D, and if it's 10%, it's 100 times by 0.9, which gives 90. Okay, right, now does this all hang together with interest? Or how does it hang together with interest? So, we've got our 90 there, we've got 100 there. We also have our formula for related to D equals 1 minus V, which implies V equals 1 minus D. So you can see straight away our standard formulas, which we always use, highlight, it works in the same way. So if we replace the 1 minus D with a V, it would literally be that. And I would be something like that. We can work it through. You'll have you've got all the ammo there per annum. Let's do the obvious thing. Let's do 90 multiplied by 1.1111, and that equals 99. So I've put a dot in the wrong place there. 0.999, which is 100. Good. Right, okay, so that's the basics. So remember this 1 minus D, how this is applied. Where do we use this a lot? Well, we use, so I've put use, we use, excuse some of the noises, my dog is awake and getting hungry, it appears, or certainly my feet are feeling like sausages at the moment. Right, so use. We use this for annuities again. So annuities due, or annuities advance, as you know I call them. I don't really like that term due. So so the A double dots N. So 1 minus V to the N over D, and then we use them for the more frequent or different frequency than annual annuities, like that. They're also used explicitly for treasury bills. So your treasury bills are described briefly, but importantly, in your notes. So you really should understand how they work. They're obviously, when we see treasury, we think one of the government agencies. Well, they're US bonds really, and they agree to pay, say, 100 in 5 years' time, and then from that, you're given the D for them, say 5% this time per annum, and the fair price would be, hopefully this is coming out on the screen still, the fair price would be 100 multiplied by 1 minus D to the 5. So again, this is the multi-period formula there, a more general form than the formula we used earlier on up here. for your exams, there's one other key thing you need to learn, and that is the formula for the nominal rate of discount. You can understand the mechanics of this. You don't need to derive it. We didn't derive it in the lectures, so you won't be asked that in exams. I don't think that's unfair to say that. So it looks very similar to the nominal rate of interest. So we've got the nominal rate of discount, we've got the P here, and then the 1 minus, and in brackets 1 minus the effective rate of discount to the power of 1 over P. That needs to be learned. Once you've got that, you can then apply this to annuity questions fundamentally, of which, you know, we've done some useful types through the course, so make sure you understand that. Okay, I think that is it for now. Oh, there's one other early formula actually. D equals I over 1 plus I. Yeah, so that can be derived from there, but once again, it's worth having that in your head just in case you need it. Okay.